All right, ready to dive into some seriously cool machine learning research.
Always up for that. Where are we headed today?
Today, we're tackling ensemble selection from libraries of models.
Okay, sounds intriguing. I'm guessing, based on the title, that it involves more than one model.
You got it. It's all about harnessing the power of multiple models to make crazy accurate predictions.
Ah, the wisdom of the crowd approach? But for algorithms, I'm intrigued. Tell me more.
So picture this. Instead of relying on just one expert, you have access to thousands, each with a slightly different take on the problem.
It's like having a room full of specialists, each bringing their unique knowledge to the table. I can see how that would lead to a more well-rounded analysis.
Exactly. And that's the beauty of ensemble methods in machine learning. But this research takes it a step further.
Oh, how so?
Instead of just gathering any old models, they create a massive library of these models. Think of it like a giant repository of prediction power.
A library of models. Now that's an interesting concept. What kind of models are we talking about here?
We're talking the whole gang. Support vector machines, neural networks, decision trees, you name it, they're all in there.
Wow, they really went all out. And I bet they carefully selected only the best performing models for their library.
That's where it gets even more interesting. They didn't just pick the usual suspects, the ones known for being top performers. They included everything.
Wait, even the models that might not be winning any awards on their own? The ones that might seem, well, kind of average?
You got it. They wanted a truly diverse collection, believing that even those average models hold a piece of the puzzle.
That's fascinating. It's like they're saying every model has its own unique strengths, even if it's not the shiniest tool in the shed.
Precisely. And by having this huge range of models, even the ones that might seem subpar on their own, they increase the chances of finding those hidden patterns in the data.
Ah, I see. It's about embracing the diversity of perspectives, just like in a good team. You don't want everyone thinking the same way.
Exactly. Now here comes the really cool part. Instead of just throwing all these models together and hoping for the best, they developed a clever algorithm for ensemble selection.
Ensemble selection. So it's not just about having a massive library. It's about choosing the right models for the job.
You got it. This algorithm acts like a master conductor, carefully evaluating each model's strengths and weaknesses.
So let's say your goal is to achieve super high accuracy in your predictions. This selection process would identify the all-star team of models that, when combined, give you the most accurate predictions possible.
Exactly. It's like having a custom-built prediction machine tailored for a specific purpose.
That's incredible, but I imagine this selection process goes beyond just accuracy, right?
You're right on the money. Sometimes it's about minimizing certain types of errors, which might be more critical than overall accuracy.
That makes sense. Or maybe you're trying to maximize a specific outcome, even if it means making a few trade-offs in other areas.
Precisely. This method is all about flexibility and tailoring the ensemble to the specific needs of the problem.
It's like having a Swiss Army knife of prediction models. So much potential.
Okay, let's bring this down to earth a bit. Where would this actually make a real-world impact?
Well, the researchers put their method to the test using various data sets, and one example that really stood out was their work with a particle accelerator.
Whoa, that's getting into some seriously high-stakes prediction. What are they trying to predict?
They were focused on improving the classification of subatomic particles. Talk about a tiny margin for error.
Wow, that is high pressure. And I imagine even small improvements in accuracy could have huge implications in that field.
Absolutely. Even a tiny improvement could translate to massive savings in research costs and time. We're talking millions of dollars potentially saved.
Now that's what I call impact. It's amazing to see how these seemingly theoretical concepts can have such tangible real-world applications.
It's a good reminder that machine learning isn't just some abstract idea. It has the potential to revolutionize countless fields.
You mentioned they tested this on different data sets. Any other findings that you found particularly surprising or intriguing?
Absolutely. One discovery really highlights the power of this whole selection process, and it might surprise you. They found that simply averaging the predictions of thousands of models wasn't always the best approach.
Really? I would have thought that more models would always equal better accuracy,
Yeah.
kind of like getting advice from 1,000 people instead of 10.
Right, it seems intuitive. But surprisingly, they found that a smaller, carefully curated ensemble often outperformed the massive crowd.
Wow, that's fascinating. So it's not just about throwing more algorithms at the problem, it's about strategically choosing the right ones for the task at hand.
Exactly. It all comes back to that theme of thoughtful selection and understanding what each model brings to the table.
Quality over quantity. Now, there's one more thing I wanted to touch on, bagging. What is that, and how does it fit into all of this?
Ugh, bagging. Imagine you're studying for a big exam, and you want to make sure you really understand the material, not just memorize it. That's what bagging helps achieve in machine learning.
Okay, so it's about making sure the models aren't just cramming the data.
Exactly. We call that overfitting, and it's a common problem. But with bagging, we create multiple smaller study groups of models, each trained on a slightly different subset of the data.
So it's like giving each group a slightly different perspective on the material, which helps them develop a more well-rounded understanding.
Precisely. By combining the predictions from these diverse study groups, we end up with more accurate and reliable overall results. It's like getting multiple expert opinions before making a big decision.
That makes a lot of sense.
It's like we're assembling a dream team of experts, each bringing their A game to the prediction table.
Exactly. This idea of building these model libraries, being able to tap into this incredible predictive power, it feels like we're on the edge of something massive.
It's definitely a game changer. This research gives us a glimpse into a future where leveraging advanced machine learning doesn't require, being a coding whiz.
It's like democratizing access to powerful predictions. Need to predict customer behavior, optimize a supply chain, maybe even personalize medical treatments. There could be an ensemble for that.
Precisely. The possibilities seem almost limitless, but of course, with great power comes great responsibility, right?
Absolutely. As we delve deeper into this world of powerful predictions, we need to be mindful of the ethical implications. It's a conversation that needs to happen alongside these technological advancements.
100%. We can't just focus on what's possible. We have to consider the potential consequences as well.
Speaking of details, there's one term from the paper that caught my eye. Probability calibration. It sounds pretty technical, but I have a feeling you can break it down for us.
Definitely. Probability calibration is all about ensuring a model's confidence levels match up with reality. It's one thing for a model to make a prediction, but we also want to know how much we can trust that prediction.
So it's not just about saying, hey, this might happen. It's about saying, we're 80% sure this will happen.
Exactly. Let's say we're using a model to predict, for example, customer churn. A well-calibrated model won't just tell you if a customer might leave, it'll give you a probability, like this customer has an 80% chance of churning, and importantly, that 80% should be based on real-world data.
So if we looked at 100 customers with that 80% prediction, we should see roughly 80 of them actually churning. It's about making sure the model's confidence is backed up by its actual performance.
Exactly. And this calibration becomes particularly critical in fields like finance or healthcare, where decisions based on these predictions carry a lot of weight.
Absolutely. You wouldn't want a model making overly confident predictions about investments or even riskier medical diagnoses. Calibration adds that extra layer of trust and reliability, making sure those predictions are not just accurate, but also something you can feel confident acting on.
You've got it. Now, what's interesting is that the researchers found that different ensembles, even when they were designed for accuracy, could vary quite a bit in their calibration.
So a model that's great at making accurate predictions might not be so great at accurately expressing its confidence levels.
Exactly. It's a good reminder that we need to consider multiple aspects of a model's performance, not just how accurate its predictions are. And this selection process, it gives us the tools to fine-tune and optimize for those specific needs.
It's like we talked about earlier, sometimes a smaller, more specialized team of models can outperform a massive ensemble. It's not just about the quantity of models, but how well they're chosen and how well they work together.
Absolutely. It's about understanding the strengths and weaknesses of each model and using that knowledge to build a truly effective ensemble. And that's what this research offers, a powerful framework for doing just that.
It really makes you appreciate the ingenuity behind this research. By carefully picking and combining these models, we can achieve incredible accuracy and gain insights that were unthinkable just a short while ago.
It's a testament to just how quickly things are moving in the field of machine learning. And this research, it's really pushing the boundaries of what we thought possible.
Totally. And it gets me thinking, what does this mean in the grand scheme of things? Having this kind of predictive power at our fingertips, it feels like we're entering a new age of decision-making.
It's pretty mind-blowing when you think about it. As these models become more sophisticated, it raises some big questions. How will this change the way we deal with complex problems? Are we headed toward a world where data-driven decisions are the norm in all sorts of fields?
It's like we're getting a whole new way of looking at the world, of making sense of all this information. But of course, with this ability comes a responsibility to use it wisely.
100%. It's not just about the technology itself, it's about the choices we make as we integrate these advancements into our lives. It's a much bigger conversation than just algorithms and data science.
It reminds us that no matter how powerful these technologies become, human judgment and ethics are more important than ever. It's not just about building smarter machines, it's about creating a smarter, more informed future.
Beautifully put. That's what makes this research so exciting. It's not just about pushing the limits of what machines can do, it's about using those breakthroughs to better understand the world around us and tackle the big challenges.
This has been an amazing deep dive. We've covered so much ground, from how this ensemble selection actually works to the larger impact it could have. It's
Yeah.
clear that we're only just beginning to explore the possibilities of machine learning.
The future's looking bright and fascinating.
Couldn't agree more. But as always, we want to leave our listeners with something to ponder. As we unlock these incredibly powerful prediction models, what do you envision for the future of decision-making? Can we strike a balance between human intuition and these algorithmic insights?
Now, that is the million-dollar question, isn't it? It's one we'll all be grappling with as these technologies keep evolving. But one thing's for certain, it's going to be a fascinating journey.
And on that note, we'll wrap up this deep dive. A huge thanks to our expert for joining us, and to you, our listeners, for exploring this fascinating topic with us. Until next time.